We're just going to look at one more example on how to use trig to find a missing angle of a right triangle given two sides. All right, so what I've done here is I've recreated the diagram on my paper. We want to find the measure of angle M to the nearest degree. So I've redrawn the diagram. There's angle M. I don't know its value, so it's going to be x degrees. So I have to use my sine, cosine, and tangent, one of those functions, to help me. So before I do that, I have to label my three sides of my diagram. So my hypotenuse would be across from the right angle. That's the 9.5 side, the MN. My opposite side is across from the angle that we're dealing with. So angle X would be our reference angle. The opposite side is this unmarked side. Therefore, the side of 5.5, side MO or OM, is the adjacent side. So we're really dealing with our hype and our adjacent because they're both marked with something. Our opposite side is not marked. We're not dealing with that. So we're not dealing with opposite side. We're only dealing with adjacent and hypotenuse. So notice how for this problem, we're going to use cosine. All right, so you can use cosine, you can use sine, you can use tangent, depending upon which sides are marked in the diagram. Once we decide who we're going to use, we're going to set up the equation. All right, so we're going to do cosine x, again, because that's the angle, equals blank over blank. So we need to do adjacent over hypotenuse. Adjacent is 5.5, and hypotenuse is 9.5. All right, so that's my setup. Again, I don't know my angle, so I can't do a proportion. When I don't know my angle, when my angle is unknown, I do second cosine in my calculator, which gives me the cosine -1 or inverse cosine function. So I'm going to clear out what I have and do second cos. And then now I'm going to type in my ratio. So my ratio is 5.5 divided by or over 9.5. So I'm going to type that in. All right, so that gives me approximately 54.6. So that they want that to the nearest degree again, so that would be like 55 degrees. Rounds up to 55. So that's my answer. That angle in the diagram is 55 degrees, and that's what I would put as my answer on delta. So that's how you would find a missing angle. You always have to use the second cosine, sine, or tangent functions. Make sure you're using second rather than the regular sine, cosine, and tangent that you do when you're finding a missing side. If you don't have your graphing calculator with you, I actually looked on Google. I Googled scientific calculator, and this is what comes up. Notice how they have the regular sine, cosine, and tangent functions if you need those when you're finding a missing side, which is cool. But then let's say you're finding a missing angle. If you hit the this button, INV, inverse, notice how like sine -1, cosine -1, and tangent -1 come up. So that's what you would use to get like something like what we just did, that second cosine or inverse cosine function. But if you just need it to be regular, you could like keep clicking it. It'll switch back and forth. If you're finding a missing side, you would just use the regular function, sine, cos, tan, without the -1 on it. Okay?